To select the correct conductor for a 100 amp three-phase panel, several factors must be considered, including ampacity, cable type, grounding, and applicable electrical codes. According to Table 400.5, thermoplastic insulated, oil-resistant cables can support 100 amps ampacity for 3 current conductors. These include SU, extra hard usage, SO hard usage, and thermoplastic insulated, oil-resistant. However, since a 5-conductor cable is needed, Table 400.5, B for multi-conductor cables should be referenced. Suitable cables listed in this table are PP, portable power equipment, G, general use, and GGC, general use with grounding conductor. Based on availability and cost considerations, PP cable is often recommended. It is specifically designed for portable equipment and meets the ampacity and voltage requirements for the panel. For a 100 amps ampacity and 208 volts application, a 3/0 American wire gauge PPE cable should be sufficient. Firstly, ensure that the pin and sleeve plug is rated for 3-phase, 100 amps, and 208 volts. Secondly, use proper grounding practices by connecting the grounding conductor to the equipment frame and the ground terminal in the panel. Thirdly, install the cable in a protected location to avoid damage. Finally, follow all applicable electrical codes and safety regulations. When selecting a cable, it's crucial to understand the different types and their applications. SU cables are known for their durability and resistance to oil, making them suitable for harsh environments. SD cables are a more economical option for lighter-duty applications. PPE cables are specifically designed for portable power equipment, providing flexibility and durability. G and GGC cables are general-purpose cables that can be used in a variety of applications, with GGC including a grounding conductor. To ensure safety and compliance, always refer to the National Electrical Code, specifically Article 400, which covers flexible codes and cables. This article provides detailed information on ampacity, conductor types, and allowable uses. When working with electrical equipment, always prioritize safety. To energize the circuit before making any connections or modifications, use appropriate personal protective equipment such as gloves and safety glasses. If unsure about any aspect of the installation, consult with a qualified electrician. Grounding is a critical aspect of electrical safety. The grounding conductor provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Ensure that the grounding conductor is properly connected to the equipment frame and the ground terminal in the panel. The size of the grounding conductor should be based on the size of the ungrounded conductors, as specified in the National Electrical Code. Overcurrent protection is another essential safety measure. The circuit breaker or fuse protects the conductors from overheating and potentially causing a fire. The size of the overcurrent protection device should be based on the ampacity of the conductors, as specified in the National Electrical Code. Avoid oversizing the overcurrent protection device, as this can defeat its purpose. When installing the cable, ensure that it is properly supported and protected from damage. Avoid running the cable through sharp edges or areas where it could be subjected to abrasion. Use appropriate cable clamps or connectors to secure the cable to the panel and the equipment. Flexible cords and cables should not be used as a substitute for fixed wiring. If the application requires permanent wiring, use the appropriate type of cable, such as non-metallic sheath cable or electrical metallic tubing. When working with 3-phase power, it's important to understand the different voltage configurations. 208 volts is a common voltage for 3-phase power in commercial and industrial applications. Other common voltages include 480 volts and 600 volts. Ensure that the equipment and wiring are rated for the correct voltage. Voltage drop is another factor to consider when selecting conductors. Voltage drop is the decrease in voltage that occurs along the length of the conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, use larger conductors or shorten the length of the cable. The National Electrical Code provides guidelines for calculating voltage drop. In summary, selecting the correct flexible cord for a 100 amp 3-phase 208 volts panel requires careful consideration of ampacity, cable type, grounding, overcurrent protection, and applicable electrical codes. PPE cable is often recommended for portable equipment due to its stability and flexibility. Always prioritize safety and consult with a qualified electrician if unsure about any aspect of the installation. Remember to always consult the most recent edition of the National Electrical Code for the most up-to-date requirements and guidelines. These codes are updated regularly to reflect changes in technology and safety standards. Failure to comply with these codes can result in serious consequences, including fines, injuries, and even death. When selecting a pin and sleeve plug, ensure that it is rated for the appropriate voltage, amperage, and number of poles. The plug should also be compatible with the cable being used. Use a plug that is specifically designed for flexible cords and cables. Avoid using plugs that are intended for fixed wiring. When connecting the cable to the pin and sleeve plug, follow the manufacturer's instructions carefully. Ensure that the conductors are properly terminated and that the connections are tight. Loose connections can cause overheating and potentially lead to a fire. Always use the correct tools for the job. Using the wrong tools can damage the cable or the plug, and can also increase the risk of injury. When working with electrical equipment, it's important to be aware of the potential hazards. Electrical shock, arc flash, and arc blast are all serious hazards that can result in severe injuries or death. Take precautions to minimize these risks. Wear appropriate personal protective equipment such as gloves, safety glasses, and arc-rated clothing. Work in a well-lit area and avoid distractions. If you are working near energized equipment, use insulated tools and maintain a safe distance. Never work alone. Have someone nearby who can assist you in case of an emergency. Before starting any electrical work, inspect the equipment and wiring for any signs of damage. Look for frayed wires, cracked insulation, and loose connections. If you find any damage, repair it before proceeding. If you are not qualified to make the repairs yourself, contact a qualified electrician. After completing the electrical work, test the circuit to ensure that it is working properly. Use a multimeter to measure the voltage, current, and resistance. Verify that the equipment is operating as intended. If you find any problems, troubleshoot the circuit and make the necessary corrections. Keep a record of all electrical work that you perform. This record should include the date, the type of work performed, the materials used, and any problems encountered. This record can be helpful for future maintenance and troubleshooting. Electrical safety is everyone's responsibility. By following these guidelines, you can help to prevent electrical accidents and injuries. Always be aware of the potential hazards and take precautions to minimize the risks. Remember that electricity is a powerful force and should be treated with respect. If you are ever unsure about any aspect of electrical safety, consult with a qualified electrician. They can provide you with the information and guidance you need to work safely with electrical equipment. The National Electrical Code also provides valuable information on electrical safety. This code is updated regularly to reflect changes in technology and safety standards. Make sure that you are familiar with the latest edition of the National Electrical Code. In addition to the information provided above, there are a few other points to consider when selecting a flexible cord for a 100 amp 3-phase 208 volts panel. Firstly, consider the environment in which the cable will be used. If the cable will be exposed to harsh chemicals or extreme temperatures, choose a cable that is specifically designed for those conditions. Secondly, consider the flexibility of the cable. If the cable will be frequently bent or moved, choose a cable that is highly flexible. Thirdly, consider the weight of the cable. If the cable will be suspended or supported, choose a cable that is lightweight. Finally, consider the cost of the cable. Flexible cords and cables can vary in price depending on their type, size, and features. Choose a cable that meets your needs and budget. When selecting a flexible cord, it is important to consider all of these factors to ensure that you choose the right cable for the application. Choosing the wrong cable can result in safety hazards, equipment damage, and costly repairs. Always consult with a qualified electrician if you are unsure about which cable to choose. They can help you to assess your needs and select the best cable for your application. Remember that electrical work can be dangerous. Always take precautions to protect yourself from electrical shock and other hazards. To energize the circuit before working on it, wear appropriate personal protective equipment and follow all applicable safety regulations. By following these guidelines, you can help to ensure that your electrical work is done safely and correctly. When dealing with electrical systems, proper documentation is crucial. Keep detailed records of all work performed, including cable types, sizes, and connections. This documentation will be invaluable for future maintenance, troubleshooting, and upgrades. Accurate labeling is also essential. Clearly label all cables, panels, and equipment to avoid confusion and potential hazards. Use durable labels that can withstand the environment in which they are installed. Regular inspections are also important for maintaining the safety and reliability of electrical systems. Inspect cables, connections, and equipment for any signs of damage, wear, or corrosion. Address any issues promptly to prevent further problems. Consider using thermal imaging to detect hotspots and potential fire hazards. Thermal imaging can identify areas of excessive heat that may not be visible to the naked eye. Education and training are essential for anyone working with electrical systems. Stay up to date on the latest codes, standards, and best practices. Attend training courses and workshops to enhance your knowledge and skills. Encourage a culture of safety in your workplace. Promote awareness of electrical hazards and encourage employees to report any concerns. Provide regular safety training and ensure that everyone has access to the necessary personal protective equipment. By prioritizing safety, documentation, inspection, education, and training, you can create a safe and reliable electrical system. This will protect your employees, your equipment, and your business. Remember that electrical safety is an ongoing process. It requires constant vigilance and a commitment to continuous improvement.